Hi everyone, welcome back. We'll be going through chapter 6.4, the methods of sections, textbook. I'm referring to textbook page 291. Yeah. So today's objective will be to determine the forces in truss members using the method of section. Okay, so we're going to cut the truss and we're going to analyze the forces within the truss itself. So application. Okay, so why do you need and where can you apply this lesson? Long trusses are often used to construct the large cranes and large electrical transmission towers. So the method of joint requires that many joints be analyzed before we can determine the forces in the middle of a large truss. So if the truss is really very long, example like the crane here, when the crane's truss is very long, so what's actually happening in the middle? Can we increase the load? What is the phenomena that's happening to the members in the middle? This is why we are studying this chapter. Okay, so let's look at this. So if you have a force member which is under tension, okay, remember the previous lesson I said when the rod is pulled, so it is under tension. Okay, when it's being pressed, then it is under compression. So when it's being pulled, when it's under tension, when you cut the middle, so when you expose the forces, you see tension. When you join them, it will cancel off each other. So this is the internal force. Likewise for the compression. If you cut in the middle, this rod will still be under compression, this rod will still be under compression. But if you join them together, you can't see the compressive force in the middle because it cancels off each other. So in method of truss, a truss is divided into two parts by taking an imaginary cut. So it's an imaginary cut. It's an imaginary cut. Why? Because you want to study what's happening here, and what's happening here. Okay, so since the truss are subjected into tensile and compressive forces along their length, the internal forces at the cut members will either be tension or compressive. So we have tensile or compressive, either one of it. So when you join them, then it will be all cancel off, like it balance off, and there's no any forces in between here. So based on the equilibrium of particle and Newton's third law, you know that when you join them together, it will cancel off each other. Okay, the steps for analysis. So first part, you'll be given question like this, and then they will tell you where to cut. Maybe they will tell you they will draw this cut, or sometimes they will just tell you to analyze BC, GC or GF. So you decide where to cut and how to cut. Where you need to determine the forces and where the number of unknowns does not exceed 3. Usually that's what in general we keep, does not exceed 3. So decide which side of the cut will be easier to work with. Like example, this part, you can work in both sides, either one side. You can either take from this side or from this side. So take the one that's least complicated. So if required, determine any necessary support reaction by drawing the free body diagram of the entire truss. Okay, let's analyze this part. When you cut, what actually happens? I've actually cut and paste something here, this in the word. So let's go here and do some scribbling. Okay, if you join, can you see, from this side you have your FBC and then you have your FBC. They are actually in the opposite side, but when they join together, they cancel off each other. Can you see that? Likewise, GF and GF. And then we have GC and GC. You look at the direction. The direction when you join together, you will see that the direction are opposing each other and they just balance off. Okay, so when you take from the left side and this is from the right side, okay, what's the difference? When you cut from the left side, the C becomes imaginary here. Can you see this C? This is an imaginary C. You still draw the C, but it becomes the imaginary C. Okay. Likewise, when you take from the right side, then the G is there. The G is there and it becomes the imaginary G. Okay. So this is very important. These points are very important because they actually exist. It's just that when you cut, depending on where you cut, that point becomes imaginary. So this is real point. It's there, you see? It's there. Okay? But the C is imaginary. Okay? Yeah. So based on our fx equals to 0 and fy equals to 0, this is how we have to work on this, on which side that you have taken. If you have taken left, then you solve for the left. Yeah. If you've taken the right, then you solve for the right. Yeah. Okay. So let's look at how to solve a question. So I hope you can understand. Okay. Next would be to draw the fourth step is to draw the selected part of the cut truss, which part that you have cut, yeah, and then you indicate all the unknown forces, like what I've explained here. See, all this is imaginary, yeah, because when you cut from this side, you see, when you cut here, this part is no more there, right? So C becomes the imaginary. C becomes the imaginary, but you have your G. But when you cut the other side, then the G becomes imaginary. Yeah, this is very important. Yeah, okay. And then you apply the scala of equilibrium. So what is that? Your fx equals to 0 and your fy equals to 0, and you'll be using a lot of moment here. Yeah, moment at which point? Like example, you can take moment at C. Yeah, equals to 0. The moment is very important. You need to practice on moment. You have to be good in that. Yeah. Okay. So let's solve an example. Like what I have told you, I always solve examples from the textbook because it's a bit more challenging. You can look at this example by yourself, yeah, and then there's also group solving. You can just have a look at it. So let's do example 6.5 in the class now, and your homework will be 6.27, 6.237. You can find the answers on the e-learn. Okay. Okay, let's go to the example. Okay, this is from your textbook, page 294. Yeah, we're going to look at page 294. I can't move. Oh, 1 second. Okay, so this is example 6.5. yeah, let's look at example 6.5. Okay, determine the force in GE, GF, GC and BC. So GE, GC and BC. So you need to cut in between. Okay, so you have cut here. This question has actually cut for you, so it's a bit easier. Okay, so now it depends on which side do you want to solve this. So the first step would be to draw the whole free body diagram. You need to solve the whole free body diagram. Okay, so you do not expose any internal forces, you only show the external forces. Like example in D, what's a D? It's a roller, so you only have dy. And then what's in A? A is AX and AY, yeah, because it's a pin. Okay, and then we have 1200 here and 400 here. So you need to look for AX, AY and DY. So the first step is, okay, like in this example, they're given fx equals 0. So we have fx 400 and then we have the AX. So which means AX is 400. Direction is correct. That's why you get a positive answer. Next, you take moment at A. So when you take moment at A, 8 times 1200, and then dy times 12, and then we have 400 times 300. Yeah, you can see the distance, right? Okay, remember what I told you about the positive negative sign? Whatever that goes clockwise is negative. So how is the clockwise? You press the pin here and you allow this to go around. Yeah, okay, so you can solve your dy, which is 900. So with that value of dy, you can solve the ay. So you've got ay as 300. Now, since that the question is actually asking you to solve between GE, GC and BC, you have a choice whether you want to take the left side or you want to take the right side. Yeah, so the textbook has actually taken on the left side, the simpler side. So let's follow this, yeah. Okay, so you have the 300, you have the 400, and then you have the point C here, which is imaginary, and then you have the GE here, and then you have your GC and FBC. Okay. Okay, now the triangle, can you see the triangle 3 4 5? How did you get the triangle as 3 4 5? Yeah, that's because of the triangle itself. You see, this portion is 4 meters. The height of GB is actually 3 meters. So 3 4, and of course this is 5. That's your Pythagoras theorem. Yeah. So okay, let's look at this thing to solve. So you have solved for your GE, GC and FBC. Now the direction. Why is the direction kept this way, and GC is pointing down and FBC is pointing to the right? Yeah. Okay, remember what I told you in the last class? First, you draw the lines. This is like a guessing game. Okay, use your FX. Can you see this 400 is actually pointing on the left? So FBC will point on the right. Don't worry about the direction. If your answer is negative, which means the direction that you have taken is wrong. Okay, so if FBC is pointing to the left, FGE will be pointing to the FBC pointing to the right, GE will be pointing to the left. And then you have your GC. This GC have to balance this GE. So that's the reason why it's pointing down. Okay, let's work on this, yeah. Okay, the first part is to take moment at G itself to solve for FBC. So 300 times 4, 300 times distance 4, because point G, yeah. Okay, and then we have our 400 times 3 and FBC times with 3. Okay, so you get your answer as FBC 800 tangent. So did you see the answer? It is positive. So because it's positive, which means the direction that's taken is actually correct. And look at it. Why is it tangent? Because it's pulling away. Can you see the rod? It's actually pulling away. So it's under tension. Okay. Okay. Next is to solve at point C. So if you take moment at point C, you are killing the GC and FBC. You can solve for GE, right? Repeat the same method. 300 times 8, because it's 300. This is your point C here. You will not take this 400 because the distance is 0. Yeah, GC and FBC, this distance is also 0. So you only have GE. The distance of GE is 3 meters. So at the end of the day, GE is 800 compression. Okay. So the answer is also positive, which means the direction that you have guessed up here is actually correct. So it's pressing on. Can you see it's pressing on the rod? So it is compression. Okay, the last part. So we have solved for BC, we have solved for GE. Okay, the last part would be to solve for the GC. Okay. Okay, let's look. So in this part, we can just use your Fy equals to 0. So look at what is Fy, 300, and then your GC. Make it into Y direction, and then you can solve your GC as 500 tangent. So in this question, all your examples are, in your example question here, the directions are correct. So let's say if you calculate and your direction, your final answer is actually negative. So don't worry, don't panic. You just have to turn the direction around. Yeah. So with this, we have completed chapter 6.4. So your homework will be to redo example 6.6 and example 6.7. Upload it in the link that is below. Yeah. Thank you.